Hey, sixth graders, Mrs. Zimmerman here, and today we're starting a new chapter. Last Friday, you watched a few short videos on like statistical questions and kind of got a little introduction to statistics, but today we're jumping in all the way. So what we're going to be doing today is we're finding the average, basically, of a set of numbers. And my first question for you is, what does the word average mean? So for example, if I were to ask you something like, what is the average age of a sixth grader? What would you say? Probably 11 or 12, right? What is the average temperature in the summer? Well, depends, right? Sometimes it's 80, sometimes it's 70, sometimes it even gets up to 100. But when we talk about the average, we just want to know what's normal, what's in the middle. Same with like the age of the sixth graders, right? Some sixth graders might be 13. They're a little bit older. Some sixth graders might not even be 11 yet, but most sixth graders are 11 to 12. Same thing with the summer, the average temperature in the summer. And there's actually a mathematical way to calculate what that average is going to be. And we call that finding the mean. Okay, so it's like this. It's just like it sounds, finding the mean. And the word mean, that tells us that we are going to be finding the average. And there's a mathematical formula, a way to do this to find out exactly what that average temperature is going to be. Okay, so the first thing we're going to do is I looked at a few different dates from last summer and I found different temperatures for us to use. So I've got 5 different temperatures all throughout last summer from June to August. So I'm going to head to the front and I'm going to teach you how to find the average. Okay, so the first thing we want to do is actually take the data. What were the temperatures? Okay, so my first temp is 62 degrees. The next one is 75, 71, 84, and 96. Okay, once you have all of your pieces of data, you just have to add them up. So if you want to do it on paper, in your head, however you want to do it, I'm going to add these up, and all of those numbers added together is 388. Okay, now that's not our final answer. That's just all the numbers added up. The next thing you have to do is divide by how many numbers there are. I have 1, 2, 3, 4, 5. So I'm going to do 388 divided by 5. And that is 77.6. So if I were to take the average of all these temperatures, the average temperature last summer was 77.6 degrees Fahrenheit. And that's it. You add up all the values and divide by how many there are. So let's look at some more data, okay? If you look over here, I have different weights of dogs, okay? We've got all the different dogs and how much they weigh. So because I have them all here, let's write out our data. We are talking in pounds. How much are these going to weigh? Okay, so we have 18 plus 9 plus 60 plus 89 plus 44 plus 13 plus 54 plus 45. Okay, pause. All right, now that I have all my data lined up, we are going to add them together. Again, if you want to put it into a calculator, you can, or just work it out here on the paper. But I've added them up, and it comes to 332. Now that I've added it, I'm going to divide by how many numbers there are. 1, 2, 3, 4, 5, 6, 7, 8. So divide that by 8, and we get 41.5. And I know we're talking about pounds, so I'm going to put the label pounds. And that's it. That's the average of those particular dogs. There's the mean. We call this finding the mean. Okay? Let's try another one. Okay? Oh, here, we're talking about pets again. How many pets do people own? And this time you see we have tallies here. So I'm going to write the numbers off to the side. 1, that's 3, 2, 4, and 0. We're going to add those together. You'll get 10. Okay. And now once I've added them together, I have to divide by how many numbers there are. 1, 2, 3, 4, 5 numbers. So 10 divided by 5 is 2. The average number, the mean number of pets owned is 2 pets. Okay, so we're just going to stop there at 3 examples. You add up all the data and then divide by how many numbers there are. It's pretty straightforward. Okay, so that's how you find the mean. Now, the next thing we're going to look at is, let's see. Okay, so this bar graph shows the monthly rainfall amounts for 2 cities. Compare the mean monthly rainfalls. Okay, so here's what we have here. Okay, we've got city A, which is the darker green, and city B, which is the lighter green color. And we need to compare the mean monthly rainfalls. Okay. So what I'm going to do is start with city A, and we'll do city A in green. Okay, I need to take all the values from city A and write them down. So that way I'm going to be able to add them together. So here we go. 3.5, 2.2, 1.9, 2.1, 2.5, and 3.4. Okay, if you're not sure where I got those numbers from, it was just the darker green. Okay, so these ones right here in the darker green. And once you add those all up, you will get 15.6. And now we need to find the average. So we're going to divide by 1, 2, 3, 4, 5, 6 numbers. So 15.6 divided by 6 equals 2.6, and we're measuring in inches. So the average amount of rain in city A is 2.6 inches. Next, we're going to do city B. So we're going to list off all the numbers. 1.7, 1.6, 2.2, 2.1, and what's last? 2.7 plus 1.7. Sorry, I'm trying to write these and add them at the same time. Okay, there we go. So we've got all of our numbers lined up. We're going to add them together, and this time you will get 12. And we have the same amount of months that we're comparing, so we're just going to do 12 divided by 6, which equals 2 inches. So let's take a look at our means. They want us to compare the mean monthly rainfalls. So in city A, there's 2.6 inches, and in city B, there's 2 inches. So if I were going to compare these, I would need to write a complete sentence. So we could say something like, when comparing the means of city A and B, comma. What do we notice? Who gets more rainfall? City A by 6/10. Okay, so when we compare these, when comparing the means of city A and B, you notice city A receives 6/10 of an inch more than city B. There you go. Okay, that's how you compare them. You do the mean of both, and then see what's the difference between the two, okay? So now we know how to find the mean. We know how to compare means. The next thing we're gonna do is look at something else, okay? Another thing that we have to kind of be aware of when we're finding averages. So the first is looking at these shapes. And if I asked you, look at these shapes and tell me what doesn't belong. Pretty obviously, what doesn't belong? The green circle, right? The green circle doesn't fit in with the rest. It's not the same. In math, we call that an outlier or an outlier, either one. So what does that actually mean? Okay, let's take a look at this data. It is asking us to find the outlier. Okay, so we've got all these different numbers. We want to find the number that doesn't belong. So I'm just going to start. I see a bunch of numbers in the 70s. So I'm going to underline those in blue because I know that's going to be our base. I've got numbers in the 70s. I've got a 77 and an 84. Those are pretty close together. And my 73 and 68 are pretty close together. Does 38 match any of the rest, or sorry, 31, does it match any of the rest of the numbers? No. Okay, so we would say the outlier of this data is 31. Oh, so I got another set. Okay, here, what do I see? Well, I see numbers in the 30s, more than one of them. I see numbers in the 40s. So what's the number that doesn't fit? 83 is my outlier. Okay, now that you can identify an outlier, you can use that to see what effect does this have on the mean, on the average of these numbers. So let's take that first set of data. Okay, we already found out that 31 is going to be our outlier. Okay, so I want to find the average, I want to find the mean with the outlier. Okay, so I'm going to take those numbers, 75, 84, 73, 68, 77, 31, and 74. If you add those all up, you get 482. Divided by how many numbers? 7. And you're going to get kind of a wonky number, but we'll just round and we'll call it 68.9. And that's with the outlier, with this random 31. Let's do without. Okay, so we're going to take this same set of data, but we're not going to use the 31. So we're going to do 75, 84, 73, 68, 77, and 74. And add those up. You get 451. And how many do we have this time? Well, we have one less, so we're actually going to divide by 6. And we get 75.2 if we round. So what effect does the outlier have on the mean? Well, if I have the outlier, my average is 68. If I don't have the outlier, it's 75. So having an outlier in there, an outlier in this case, lowers the mean. See how we have 68 there with it? Let's do one more like that, just to make sure. So we're going to take this, so we're going to do this set of data again. And like I said, we've already identified that 83 is the outlier. So I'm going to do with first. I'm going to take those numbers, 46 plus 39, 38, 47, 45, 34, and 83. Add them all up. You get 332. Divide by 7. And we get 47.4. Now I'm going to do it without. Find the average, but this time don't use the 83. So we're just going to add together the rest of the numbers. And when you add those up, you get 249. And we have to divide that by 6 this time. We get 41.5. So in this case, what does the outlier do? We go from 47 to 41. So in this case, because the outlier is bigger than the other numbers, an outlier raises the mean because it's bigger than the other numbers in that set of data. So now that you know how to find the mean, you can use this in a lot of different situations. You want to know the average of literally anything, add them up and divide by the same number. And also, the outlier is the number that doesn't belong, and that can change the average of whatever set of data you're working with. Okay? So watch this again if you need to, but that's it. That's my lesson for today. I'll see you next time.